Welcome to this model. In this model, we are going to see about the flow and error control in data communication networks. Data communication requires at least two devices working together, one to send, the other to receive. Even such a basic arrangement requires a great deal of coordination for an intelligible exchange to occur. The most important responsibilities of the data link layer are flow control and error link control. Collectively, these functions are known as data link control. Flow control coordinates the amount of data that can be sent before receiving an acknowledgement and is one of the most important duties of the data link layer. In most protocols, flow control is a set of procedures that tells the sender how much data it can transmit before it must wait for an acknowledgement from the receiver. The flow of data must not be allowed to overwhelm the receiver. Any receiving device has a limited speed at which it can process incoming data and a limited amount of memory in which to store incoming data. The receiving device must be able to inform the sending device before those limits are reached and to request that the transmitting device send fewer frames or stop temporarily. Incoming data must be checked and processed before they can be used. The rate of such processing is often slower than rate of transmission. For this reason, each receiving device has a block of memory called a buffer reserved for storing incoming data until they are processed. If the buffer begins to fill up, the receiver must be able to tell the sender to halt transmission until it is once again able to receive. So, flow control refers to a set of procedures used to restrict the amount of data that the sender can send before waiting for acknowledgement. And error control is both error detection and error correction. It allows the receiver to inform the sender of any frames lost or damaged in transmission and coordinates the retransmission of those frames by the sender. In the data link layer, the term error control refers primarily to methods of error detection and retransmission. Error control in the data link layer is often implemented simply. Anytime an error is detected in an exchange, specified frames are retransmitted, and this process is called automatic repeat request. Error control in the data link layer is based on automatic repeat request, which is retransmission of data. Flow control can be implemented by using two buffers, one at the sending data link layer and the other at the receiving data link layer. A buffer is a set of memory locations that can hold the packets at the sender and receiver. The flow control communication can occur by sending signals from the consumer to the producer. When the buffer of the receiving data link layer is full, it informs the sending data link layer to stop pushing the frames. So, as I said, error control is in the data link layer is based on automatic repeat request, which is a retransmission of data. In the error control at the data link layer is normally very simple and implemented using one of the two methods. That is, in one method, what we are going to do is a CRC will be added to the frame header by the sender and checked by the receiver. In the first method, if the frame is corrupted, it is silently discarded. If it is not corrupted, the packet is delivered to the network layer. And this method is used mostly in wired LAN such as Ethernet. In the second method, if the frame is corrupted, it is silently discarded, and if it is not corrupted, an acknowledgement is sent to the sender. Now let's see the protocols. There are many types of protocols called connectionless and connection oriented protocol. And before going into this, now let's see the simplest protocol, that is our first protocol, which will call simplest protocol for lack of any other name, is one that has no flow or error control. In a connectionless protocol, frames are sent from one node to the next without any relationship between the frames. That is, each frame is independent. And the connectionless here doesn't mean that there is no physical connection between the nodes. It means that there is no connection between the frames. Whereas in connection oriented protocol, a logical connection should be first established between the two nodes. After all frames that are somehow related to each other are transmitted, the logical connection is terminated. The frames are numbered and sent in order. And if they are not received in order, the receiver needs to wait until all frames belonging to the same set are received and then deliver them in order to the network layer. The connection oriented protocols are rare in wired LANs, but we can see them in point-to-point protocols, some wireless LAN and some WANs. Now the protocols are divided into two categories, that is for noiseless channel and for noisy channel. And the noiseless channels are those that can be used for noisy, that is error creating channels. Noiseless channels are error free channels. The protocols in the first category cannot be used in real life, but they serve as a basis for understanding the protocols of noisy channels. There is a difference between the protocols and those used in real-time networks. All the protocols which we are going to discuss now are unidirectional in the sense that the data frames travel from one node called the sender to another node called the receiver. Although special frames called acknowledgement and negative acknowledgement can flow in the opposite direction for flow and control purposes, data flow in only one direction. With this assumption, we'll continue, right? So in real life network, the DataLink protocols are implemented as bidirectional data flow in both directions, and in these protocols, the flow and error control information such as acknowledgement and not acknowledgement is included in the data frames in a technique called piggybacking. Because bidirectional protocols are more complex than unidirectional ones. And now first let us understood by unidirectional protocol. Now let us first assume that we have an ideal channel in which no frames are lost or duplicated or corrupted. And in this for this type of channel, we can introduce two protocols. The first is a protocol that doesn't use flow control, and the second is that one that does. And of course, neither has error control because we have assumed that the channel is a perfect noiseless channel. In simplest protocol, like other protocols, it is a unidirectional protocol in which the data frames are traveling in only one direction from the sender to receiver only, right? And we assume that the receiver can immediately handle any frame it receives with a processing time that is small enough to be negligible. The data link layer of the receiver immediately removes the header from the frame and hands the data packet to its network layer, which can also accept the packet immediately. And in other words, we can say that the receiver can never be overwhelmed with incoming frames. And there is no need for flow control in this scheme. The data link layer at the sender side gets data from its network layer, makes a frame out of data and sends it. The data link layer at the receiver side receives a frame from its physical layer, extracts data from the frame, delivers the data to its network layer. The data link layer of the sender and receiver provide information transmission services for their network layers. The data link layers uses the services provided by the physical layer, and they can also use signaling, multiplexing, some other thing for the physical transmission of bits. Now we need to collaborate on the procedure used by both data link layers. The sender side cannot send a frame until its network layer has a data packet to send, and the receiver side cannot deliver a data packet to its network layer until a frame arrives. So if the protocol is implemented as a procedure, now we need to introduce the idea of events in the protocol. The procedure at the sender side is constantly running and there is no action until there is a request from the network layer. The procedure at the receiver side is also constantly running, but there is no action until notification from the physical layer arrives. Both procedures are constantly running because they do not know when the corresponding events will occur. So the algorithm now has an infinite loop where the few steps have to be repeated and the algorithm is event driven only, which means that it sleeps until an event backs up. This means that there may be undefined span of time between the execution of the lines, that is get data and make frame and send frame. Now let's move on to next protocol called stop and wait protocol. So if the data frames arrive at the receiver side, then faster than they can be processed, the frames must be stored until their use. Now let's see the diagram. So here normally the receiver doesn't have enough storage space, especially if it is receiving data from many sources. So this may result in either discarding of frames or denial of services. So to prevent the receiver from becoming overwhelmed with frames, we somehow need to tell the sender to slow down. There must be feedback from the receiver to the sender. So because the sender sends one frame, it stops until it receives confirmation from the receiver, which means that okay, go ahead, and then it sends the next frame. So we still have unidirectional communication for data frames, but auxiliary acknowledgement frames, it's a simple token of acknowledgement travel from other direction also. We add flow control to our previous control. So we can see the traffic on the forward channel and the reverse channel. At any time there is either one data frame on the forward channel or one acknowledgement frame on the reverse channel. So we therefore need a half duplex line. Thank you.